Okay, so we're going to learn today another method of solving linear systems and inequalities. Solving systems of linear equalities. Okay, this method is called the elimination method. It's sometimes also called the addition method. And I'll tell you why in just a moment. Okay, so example 1. Suppose the sum of two numbers is 15. What does the word sum mean? Yeah, answer to an addition problem. And then the difference is 12. What does the difference mean? Subtraction. One way to figure out what these two numbers would be to guess and check. So you could just keep, adding two numbers together and then subtracting them and adding them and subtracting them. But that's, again, if I say two numbers add to 15, you have an infinite number of possibilities, especially if you consider decimals and fractions and negatives. So that's why we have to narrow it down, and we have a second criteria. That's where we get the second equation from. One way to figure this out, guess and check. Another approach is to set up and solve a system of linear equations. We're able to do this as there are two unknowns, and the two stated facts about these numbers allow us to write a system of linear equations in two variables where x and y are the two numbers. So that's really the definition. X and y are the two numbers. So they have x plus y equals 15. That's the sum of the two numbers. And then they have x minus y is 12 because that's the difference of the two numbers. Does that make sense to everybody where we get those equations? Okay, in this case, either graphing or substitution would work well. And a third method is the elimination method. So I'll just show you how this works. X plus y equals 15. X minus y equals 12. So the elimination method is called also the addition method because you take the two equations with the two variables in standard form, so they're stacked up, right? And you add them together. Well, what happens when you add them together? X plus x is 2x, okay? X times x would be x squared. What happens to y? Y minus y is what? Yes, they cancel, so there's 0, y is gone. And that adding the two equations together eliminated the y. You see why it's called the addition or the elimination method? It's the same thing. And then we have 12 plus 15 is 27. Now, how do we get x by itself? Divide by 2. X equals, what's half of 27? 13.5. Okay, so we found x. Now, you could actually, what I sometimes like to do is do the check by plugging 13.5 into both. What if I plug in 13.5 plus y equals 15? And then that's my first one. And my second one, 13.5 minus y equals 12. And then see if I get the same thing for y. If I solve them both for y and I get the same answer, then I know my answer is right. Does that make sense how I'm checking it in both by actually solving for y in both? So now I go minus 13.5. I get y equals, what is it? 1.5. And then over here, minus 13.5 minus 13.5, I get negative y equals negative 1.5. So what does that mean positive y equals? 1.5. But you see how I used both equations to make sure that I got the same y value in both. So I actually solved for y and checked it at the same time because I had to also do it in the second one. I do it in the first and the second one. So we always need two checks. Each check counts for 1 point. Okay, so if you don't have two checks, if you just solve and you give me the answer, but you don't check it in both, then that would count for 2 points. So now we would say the numbers, let's answer it in a question. The numbers are 13.5 and 1.5. Kind of fun, right? So here's the whole process, and we always want to have them written in what's called standard form. So this right here, ax plus by equals c, is called standard form. It's not getting y by itself. So whereas in the substitution problem, you're trying to get a variable by itself, here you wouldn't want to do that. If necessary, we're going to multiply either equation or both equations by the appropriate non-zero numbers so that the coefficients would add to 0. Basically so that they're, like, notice that the coefficient here is 1 and the coefficient here is -1. Since 1 plus -1 equals 0, that is what allows those two variables to cancel out when we add. So that's what this is saying right here. Sometimes they're not already set up that way. I'm going to show you an example on the next page. Then we're going to add the equations together. The sum is going to allow the equation to have one variable. And then solve the equation in step 3, and then go back and substitute it to get the other variable, and then check. Always check in both. So I kind of did a combination of 5 and 6, but anytime somebody gets the wrong answer, it's because they really didn't check it. Or they checked it and their check didn't work out. Oh, I saw that. That's kind of a nifty thing. If you know the answer is wrong, just don't check it all the way. No, I'm just kidding. I saw that happen on the quiz. Sometimes people, they were like, I know this is maybe the wrong answer, but I don't want it to look like it is. So then they just don't finish the check. They just start it. That's sort of creative. I mean, at least you're on the right track. I think that's kind of creative. Okay, let's look at this one now. If we look at the first one, you can see that if you were to add these two together, okay, I'm just going to add them up top. If I were to add them together now, I would get 4x plus 7y equals 14. But the problem with that is neither variable eliminated. So we have to change something so that they're opposites. Same number, opposite signs. What could we do? So this is wrong, by the way. We don't want to do that. That did not help us solve the problem. So we need to get one of the equations so that it has the, what would be the easiest to eliminate, do you think, right off the bat? Yeah, the x's or the y's, that's what we're choosing between. The x's, because the x's already have 2x as the coefficient. One of them needs to be negative. So actually, if I want to make one of them negative, what could I do to make the 2x negative? -1. And that basically changes the sign of everything, right? If I multiply the second one, multiply by -1, all that does is change the signs of everything. You see how that works? Yeah? You're with me? Okay, good. Now we're going to add them together. I could rewrite it, but I'm just kind of lazy. So what do we have? 2x minus 2x is what? 0. Good. 4y minus 3y is y. I was thinking you were asking me why. No, that's what the answer is, y. Okay, 6 minus 8 is? Look at how easy that was. We solved for y already. Now I'm going to go ahead and my checks, I'm going to check and solve for x in the first and in the second. So I'm going to take the first equation. Now it's important to always use the original equation. So in the original equation, I'm going to write 2x plus 4 times -2 equals 6. Then I'm going to go down here. I'm going to do the same thing. 2x plus 3 times -2 equals 8. I used the original equation for the second one because if you make a mistake changing your equation, then you'll get the wrong answer. Does that make sense? So I always want to go back to the original equation. Yes? Oh, yes. Why? Why could you do that? Well, you could. You're right. The thing is that you can always multiply both sides of an equation by anything you want. Always. That's actually the whole idea behind clearing fractions. We can clear fractions because we're like, well, I can do whatever I want to your equation, so long as I do the same thing to both sides. Why -1? It's because if I add 2x and negative 2x, I get 0x. So now I don't have, that's how we eliminate, right? Yes, exactly right. Exactly right. And maybe it would be better just to talk about that because like we pretty much know how to solve it the rest of the way from there, right? Yeah, exactly. Like if with clearing fractions, you're like, oh, I want to multiply both sides by the lowest common denominator so that I can get rid of the fractions. We might have one. Maybe we'll see if we can get to a fraction one. That would be good, right? Let's just actually, instead of finishing this one, why don't we just go to this one and talk about what would we need to multiply both sides by and which equation in order for one of the variables to eliminate. Yes? Yeah? Oh, sure. Of course. Okay, just think about for a moment, and we're going to come back and solve these. I'm just trying to get you warmed up, for that. So, what do you think? By 2. Does everybody get why he's saying multiply the top equation by 2 to clear the y? Because if I wanted to clear the x's, you know what? I would have to do a lot more work. The more work I do, the more chances I have of making a mistake. So being efficient is not only smart, it's lazy. No, it's not lazy. It's efficient. You're being efficient so that you make less mistakes. So I like that idea of multiplying this second or the first equation, both sides by 2. What will I get if I multiply both sides by 2? Plus 10y equals 16. Good, because she used the distributive property here, right? And then you get 2x minus 10y equals 12. That one stays unchanged. And then we're going to add them together, right? So what would you get if you added those together now? Eight x 28. Okay, and we might get fractions as answers. We might get decimals if they don't repeat. What do we do next? And you get 3.5. 3.5, because it's a terminating decimal, I'm okay with that. The repeating decimals is where you're going to get into problems with it not round, with rounding. But you don't have to round when it's a terminating decimal, which means it ends. And now you're going to do your check number 1 and your check number 2 by plugging this value in for x and solving for y. Always in the original. So you're going to plug in 3 times 3.5 plus 5 times y equals 8. And then you're going to go into the second one. 2 times 3.5 minus 10y equals 12. Solve for y in both of those. And if you get the same y value, that means that your answer is correct, right? It would be very unlikely unless you're forcing a mistake to happen. Sometimes that happens too, though. People want it to check so badly that they just make it check. But so you want to just be really careful about how you solve for y. Any other questions before you try? I'm going to give you a moment to try these and share out in just a moment. Yes. Yeah. You know what it's almost like? It's almost like finding the lowest common denominator when you're adding fractions. Because you see, if I was going to add 1/5 and 1/10, it would be much easier to only make a common denominator on one of the fractions than if it wouldn't be wrong to eliminate the 2 and the 3. But then you would actually, if you were going to eliminate x, you would have to multiply the top one by -2 and the bottom one by +3. You see what I'm saying? So that you could get, and it would just be, especially when you're multiplying by a negative, there's a lot of issues. So that would be another option. Option number 2 would be to eliminate x. We're just liking to pick what seems simplest. Yeah. Okay. Any other questions? Okay.